Welcome to the third video in this series on special topics in elementary mathematics. So far in this series, we've been developing models for multiplication. In the first session, we looked at two models, the rectangular array and the end-to-end model. Both of these used whole numbers. In the second session, we looked at an area model, which is one of the most powerful ways of visualizing multiplication. In this session, we're going to consider another geometric model of multiplication, one which is more process-oriented: scaling. In the end-to-end model from the first session, we laid rows of apples end to end to multiply them. We can do the same thing with lengths. To double a length, lay two copies end to end and measure the resulting length. To triple, lay three copies end to end. So it's possible to multiply a length by any whole number. For example, 6 times the square root of 2 is the length of 6 copies of the square root of 2 laid end to end. But what if we turn this around? What could the product the square root of 2 times 6 mean in terms of lengths? Or even the square root of 2 times the square root of 5? Does this product even mean anything in terms of lengths? Again, we're driven to the conclusion that multiplication is not just repeated addition, even if in some cases we can represent it that way. How to multiply a length by an irrational number is certainly the hardest question we've asked so far. It is possibly the hardest question of the whole series. So give yourself some time to think about it and search for an answer. As always, you may only have a partially formed idea, or you may have several answers. That's all fine. But try to address the concrete question: what does it mean to multiply a length by the square root of 2? I don't know what answer you came up with for that last question. I hope you took the opportunity to be creative. I have my own answer, which requires a shift to a new model. Multiplying means scaling. We know what it means to double a length because we scale it by a factor of 2. Halving a length means scaling by a factor of 1/2. We know how to compare these amounts to scaling by 1, which doesn't change anything. We'd like to know what it means to scale by the square root of 2. Essentially, we're making a comparison between ratios. When we see the square root of 2, we compare it to a size of length 1. To multiply some other length, like 3, by the square root of 2, we need to find a new length whose ratio with 3 is the same as the ratio of the square root of 2 to 1. You might think of it this way: if a pole of length 1 casts a shadow of length 3, how long is the shadow cast by a pole of the length square root of 2? Scaling is an important model for multiplication, and we use it all the time. For example, if a grasshopper can jump 20 times its body length, how far is that? Or if we know how much food it takes to feed the current world population, how much more food would be needed if the population increased by 15%? If it takes 2 cans of paint to cover 600 square feet, how much paint would we need to cover 2,000 square feet? Now, the problems I just described involved multiplying by whole numbers or fractions. But we do scale by other kinds of numbers too. For example, to find the circumference of a circle, we multiply its diameter by pi. Both the diameter and the circumference are lengths, so this is again a statement about ratios. The ratio of the circumference to the diameter is the same as the ratio of pi to 1. Try to think of some other situations that involve scaling. Post 2 or 3 of them in the online discussion forum. We've now settled on 4 visual models for multiplication: the array model, the end-to-end model, the area model, and scaling. Each has potential benefits and drawbacks, and it's good to be aware when each of them is appropriate to use. Like all mathematical modeling, this takes practice. At this point, reflect back on the first 3 videos and the 4 models of multiplications that we've used. For each of the models, try to come up with a situation in which that model can be used to solve a problem. Once you have completed your forum post for this lesson, please reply to the post of at least one other person in the discussion forum. In the next few sessions, we'll build further on our understanding of multiplication